All right, hello everybody. I'm Derek Demeter, Planetarium Director at the Emil Buehler Planetarium. I have Justin Cirillo here. He's our Planetarium Specialist and your Communications Officer. And to the right of Justin, we have Mike McConville, a Planetarium Veteran for the Emil Buehler Planetarium and Planetarium Guru. He kind of is just the all-around, just crazy planetarium guy. He's joining us today, exploring the cosmos. So what we're going to do now is we're also doing Facebook Live on these, so we're going to go ahead and initiate that right now. So let's go ahead and do that. All right, we'll go ahead and do one more quick, once it goes live on Facebook, we'll do a quick, hello everybody again one more time, just to make sure that our viewers on Facebook Live are also seeing. All right, so for those that are joining us on Facebook Live, hello everybody. I'm Derek Demeter, Planetarium Director. We have Justin Cirillo, our
Hello everyone.
and Communications Officer. And joining us today is, of course, Planetarium Veteran and Planetarium Guru, Mike McConville. Yes, he's going to be our tour guide today for our Earth's Neighborhood adventure. So kind of a little tell you about what's going on. What we're going to do is we're going to go ahead and explore our solar system. And if you have a question throughout our tour, just mention that. Justin will be monitoring the chat window if you have a question, and we will do our best to answer that there. So, of course, like all of our virtual public shows, we encourage everyone to participate and enjoy. And so what we're going to do now is we're going to go ahead and initiate. We have our UniView simulator computer here, and we're going to go ahead and initiate that. So let me go ahead and share that screen there. All right, so here we are. We are now sharing our virtual trip across the solar system. And as you can see, we are starting at our beautiful planet Earth. Yeah, you know, honestly, Earth is the best planet in the solar system, I think of, because it has everything we need, from food to Animal Crossing to Minecraft to Netflix. I mean, everything is available here on Earth. And
it is one strange rock.
It is very one strange rock. You're right about that. But there's actually one thing that's really, really unique about Earth, unlike the other planets, is that our planet is in what we call the Goldilocks Zone. I'm sure all of you guys have heard about Goldilocks and the Three Bears, right? You remember reading those?
Oh yeah, it was always just right.
It was always just right, exactly. See, we live in an area called the Habitable Zone, which is in a perfect spot in our solar system where we have the presence of liquid water. And astrobiologists and biologists think that life really needs water to kind of get the chemistry going on for the development of life. And when we find liquid water, there's a great chance we'll find life. So Earth has a lot of it, a lot of liquid water, which means obviously we have life everywhere on planet Earth. But you know, we're not going to spend time exploring Earth today. Hopefully when all this quarantine stuff is done and we're all able to go back outside and explore planet Earth, you do that and you explore planet Earth and all the beautiful stuff going on there. But what we're going to do today is we're going to explore the rest of our solar system. And we're going to start with the very first planet in our solar system. Well, actually, before that, we should probably talk about what's located in the center of our solar system. And that, of course, is our sun. And what we're going to do right now is we're going to go ahead and zoom out here. We're going to leave Earth. And we're going to take a look at kind of a bird's eye view of our solar system here. So we're going to zoom out. We're going to keep going. And eventually, we'll be able to see all the orbits of the planets. And as we zoom out even further, eventually we'll be able to see our sun. Yes, there it is. And what I'm going to do here is I'm going to go ahead and target the sun. And so that way we got the sun right in the center there. And as we zoom around here, we'll see that all the planets orbit the sun. Sun is a G2 star. It's just a yellow dwarf, an average star, nothing really super special about it. But again, because we're located about 93 million miles from this thing, it gives us the right conditions, right temperature, all that stuff for the development of life. But located, what we're going to do for the first half of our program is we're going to explore what we call the inner solar system, and we call those terrestrial planets. And so the terrestrial planets are mostly rocky, metallic. Actually, all of them are metallic and rocky. And what we're going to do is we're going to visit the first planet from the sun, and that, of course, is what? If you guys want to help me out here, what the first planet is?
That little speedy guy.
That little speedy guy, right? But that doesn't help us with the name. Mike, what do you think it
I
is?
think it's Mercury.
Yeah,
I'm
we're
pretty
gonna go
sure
to
that it's
Mercury.
Mercury.
Pretty sure it's Mercury. All right, so let's go ahead and fly down to Mercury. So what do you all think? Do you like Mercury? Do you think that Mercury is a cool planet? What's really unique about planet Mercury? Mike, do you have anything? Justin, anything you want to share about planet Mercury?
Well, the poor guy is just taking a beating.
Yeah, that's right. Mercury is inundated with craters, as we can see here. The entire planet is covered in craters. Now, a lot of these craters were actually formed during a time called the Great Bombardment. Does anyone want to talk about what the Great Bombardment was and why Mercury can kind of give us a clue of the early solar system?
Well, a lot of this is based on our theories about the birth and evolution of our solar system. And so during the Great Bombardment period, there's a lot of leftover material in our solar system from uh, number one, the formation of the sun, but then the formation of the major planets. And they've taken, you know, 99.9% of all of the real usable mass in the solar system. There's a lot of little stuff left over. And as the planets sort themselves out, we get the orbits to fall in the right place. What we see is a lot of this leftover debris falling in towards the sun. And when you happen to be the closest planet to the sun, you're going to be in the line of fire quite a bit. We know that Mercury has never really had an atmosphere too close to the sun where the solar wind is going to strip off just anything that's going to be in orbit around the planet. And because of that, there's no protection. And we see are craters here that in some cases are billions of years old. And without any sort of erosion on the planet, there's no wind or rain, we don't see any breakdown of those craters. And so for us, there is a striking resemblance to our moon. The crust of Mercury a little bit thicker. It's unlikely that any of the magma that would have been underneath the surface made it to the surface in any huge amounts in the same way that it did on our moon, where it's very, very striking, the light highlands and then the darker lowlands. But we do see areas of Mercury that show not just small craters or medium craters, tens or even hundreds of miles across, but in some cases we find things like the Caloris Basin, which is more than 1,000 miles across. Whatever impacted Mercury, this was on the very highest limit of breaking the planet apart.
Right. So
And this
real quick, this is Cloris Basin right here that I'm scrolling around with my mouse here. So continue, Mike. I just wanted to just
and then
everybody
to
see
give our viewers tonight an idea of just how huge the Caloris Basin is. It's a third of the diameter of Mercury. Mercury's diameter about 3,000 miles across. On Earth, this would stretch from Philadelphia to Orlando. So this is the entire east coast of the United States covered up by this huge impact crater. Certainly, whatever made it,
Hmm.
if something like that were to hit the Earth, it would destroy everything. Almost all living things on Earth in a matter of weeks. This is really a once in a planetary lifetime sort of impact. And the fact that we're still able to see the scars of it billions of years later, testament to just how impressive this impact was.
So Mercury, the other thing that's really interesting about Mercury is that Mercury most likely was a larger planet at some point in its history. And due to this sheer amount of solar radiation we call solar wind that's stripping off the upper layers as the planet was slowly forming and cooling down. So essentially we think Mercury is actually a skeletal remains of its once bigger self. We thought there are some guesses that Mercury could have been as big as Venus, which is pretty interesting. But I guess that's the problem with being so close to the sun. Being you're going to end up losing a little bit of your mass. Now, Justin, I know you're a big fan of space exploration. Have there been any spacecraft that have visited Mercury in the last 10 years, or are there plans for any new spacecraft to visit Mercury?
ESA actually has spacecraft on its way there now, and it's scheduled to arrive in 2025. Bepi Colombo. And
Bepi Colombo, what a
Bepi
name.
Colombo, yeah. And it is, well, Messenger, of course, was probably the most recent prior to Bepi Colombo. But yeah, Bepi Colombo is on its way there. It's really there. It'll be an orbiter, so very similar to the Lunar Reconnaissance Orbiter, the Mars Reconnaissance Orbiter, to just study that surface even more. What's interesting about space flight is it takes more time to get to Mercury than it does to get to Mars. That whole physics thing kind of gets in the way. It's pretty interesting.
One of the things that's really interesting about Mercury, and that's kind of baffled scientists for a while now, is the presence of ice on Mercury. The polar regions of Mercury, there are craters that don't get any sunlight. So there actually is deposits of water ice on the Mercurian polar regions. What do you all think of that? Do you think it's pretty astounding? Is there any other things that we may learn from the ice on Mercury?
I would dare to say it's not all that astounding at all. When you get down to its base components, water is hydrogen and oxygen. It's in hydrogen's case, the most abundant element in the universe. Oxygen is of course, many times less prevalent, but certainly is something that's created in the cores of stars, and it's something that's around the universe. You put those two fairly common elements together, you've got a cold enough spot, you're going to end up with water ice. And I think that one of our big shifts in thinking about both the history of the solar system and what other planets in the universe can be like isn't that water is rare. It's that conditions for liquid water are rare, when in fact water ice is everywhere we look. And that, of course, makes it a little bit easier for us to look at the universe and say that the conditions for life, at least the way we know it, can exist elsewhere in far more places than we thought possible.
And that's a good point, Mike, because what we're going to be doing later on is we're going to be visiting some icy worlds way out in the depths of the solar system that could very likely have life. Now, Justin, do we have any questions about Mercury from the group at all, or the Facebook chat or anything?
We do. Someone had asked, how much would I weigh? Well, first they asked, does Mercury have gravity? And it definitely does. But how much? Take it a step further. How much would I weigh on Mercury?
Well,
off the top of your head?
So Mercury is about the size of our moon. So I don't know on the top head. Mike, do you know the ratio, the gravitation?
It's roughly a quarter.
A quarter. So yeah, so basically a quarter of your weight on would be your weight on Mercury. What your quarter of your weight would be on Earth. So there you go. So yeah, you definitely want to go to Mercury if you are trying to lose a little bit of weight quickly. But but you'll see here soon that our weight is going to get really, really, really heavy once we get out to the outer solar system.
And you could get a pretty good sunburn if you were on Mercury.
Yeah,
right?
so that's another thing we forgot to mention. The Dayside of Mercury, the temperatures can get up to 800 degrees because you're facing the sun, but because it lacks an atmosphere, that heat dissipates really quickly. So when you get to the night side of Mercury, it drops down to minus 250. So very, very cold on Mercury at night. So definitely not a place where it's easy for us to explore. So
if I wanted to see Mercury in the night sky, it's pretty challenging. But what'd be the best way to do that?
So actually, Mercury is visible right before sunrise right now. If you go out right before sunrise and you have a very clear eastern horizon, you can see the planet Mercury. But it's very, very hard because it's being so close to the sun, it's not visible very often. That's kind of why it's called Mercury, because it's the messenger god. So it kind of, to the ancients, they saw it as something that was always away and gone, and it would appear every now and then. It's definitely a very challenging, and just recently we had a Mercury transit. Basically, the planet Mercury crossed in front of the sun as it was traveling the solar system. So that was actually a very, very cool way of actually seeing this little tiny world. All right, well, we're going to do, since we want to keep going, we got lots to explore in the solar system. We're going to go ahead and visit our next planet, and that, of course, is Venus. Now, while we fly to Venus, Mike, do you want to tell us about when we can see Venus in the sky? We can actually see Venus right now in the sky if we were to go outside.
You head outside and look towards the west at really any point from sunset onward, and you're going to see this brilliant white star about halfway up from the horizon to the top of the sky, what we would call the zenith. It's going to be the brightest object in the entire sky. That is Venus. And one of the reasons that Venus is so bright in our sky is the combination of its proximity to Earth. It gets closer to Earth than any of the other planets, and its abundant atmosphere. So what we're seeing here in our view of Venus is not the surface of the planet, but the top of the clouds. And those clouds reflect something like 80% of all of the sunlight that the planet receives. So in our sky, it's a brilliant star. Because of these clouds, early astronomers, and by early astronomers, we mean astronomers until the beginning of the 20th century, looked at Venus truly as Earth's twin. Roughly the same size, a few hundred miles separate us in diameter, roughly the same mass, and that means the same density. And because of these clouds, there was a real sense that Venus was a warmer, more humid version of our planet. We now know, of course, that's not the case. Venus is the hottest planet in our solar system by surface temperature. On the daytime side, we can reach in excess of 800 degrees Fahrenheit. So if you've ever wondered what it's like to stand on a planet that's the same temperature as a brick pizza oven, Venus is a close approximation of that.
So
but because the clouds are so thick, that heat is retained across the entire planet. So we have sunlight that enters through the clouds, bounces off the planet, and the heat can't escape. It's a runaway greenhouse effect on Venus. And it means that on the nighttime side, the temperatures only dip by 30 or 40 degrees Fahrenheit. It means that the rocks glow on the night side of Venus, and almost impossible to find anywhere on the planet to get away from both the extreme temperatures and the intense pressure. This is an atmosphere that's almost 100 times thicker than the one we have around Earth. And if you're at sea level and you hold out your hand is holding up roughly 100 pounds of air. We're used to that. On Venus, that's more like 10,000 pounds of air. That's a full-size elephant sitting on your hand. Would crush the human body almost instantly. There's a reason why we don't send a ton of landers to Venus. The Russians did quite a bit in the 70s and 80s. And at the very longest time, we're able to get about 2 or 3 hours out of the systems before the temperature and the pressure took their toll.
So, fun fact about Venus, too, is a day on Venus is quite bizarre. So, of course, on Earth, a day is 24 hours. On Venus, we're talking about 8 months, 8 Earth months. But a year on Venus is even more peculiar. So a year on Earth, 365 days. Venus, a Venetian year, is 7.5 months. So if you listen to that quite right, you would now know that a year on Venus is shorter than its day. So imagine creating a calendar system for Venus. The other interesting thing about Venus is actually the North Pole's on the bottom and the South Pole's on top, and the planet rotates in the opposite direction of Earth. So the sun, if you could see the sun, it would rise in the west and would set in the east. So quite a different planet. What's interesting too is that what I'm going to do here is I'm going to move the planet around, because this is essentially the view that you would see of Venus right now if you were to look through a telescope, because as Venus is traveling across the sun, we right now are only seeing half of this one side of Venus being illuminated. So we're seeing a quarter phase, just like we would see a quarter moon in our sky. So this kind of give you an idea of what you would see. But Justin, we've been to Venus, right? What are some of the missions that we've gone to? I know, Mike, you mentioned some of the Russian missions that actually landed on the surface and didn't survive very long, but have there any been really successful missions, and isn't there any missions going there now?
Oh, there have been many over the years, and mainly to study the atmosphere. What we want to find out is really everything we can about the system, because the last thing we want to happen on Earth is to end up like Venus, right? So as much as possible, what can we do to understand exactly what caused Venus to end up the way it did? Now, we know a lot about how this occurred, but further science can take this even further. And there's even some theories that maybe there is the possibility of of life on Venus. You know, it's very slim, but if you think about hydrothermal vents in our oceans, they are close to similar temperatures as well as pressures that are on Venus. So Venus is actually on NASA's radar for several upcoming missions, so we'll see. But it's just a matter of time before we go back there.
Excellent. Now, we have the ability to actually see the surface of Venus. The Magellan spacecraft actually sent radar down to the surface of Venus, and actually the radio waves were able to pierce through that thick cloud layer in the atmosphere. And so what we're going to do now is we're going to go ahead and turn off the clouds of Venus. And Mike, what can we see when we actually look at the surface of Venus here?
Well, remember what we're looking at here. This isn't a true color image by any stretch of the imagination, but because we're using radar, when the Magellan space probe in the 90s used the radar to look through the clouds, it's looking for reflectivity. It's what's on the surface that's reflecting back more or less. And what we found is that the most reflective areas have the same signature as lava. And what we see are these huge lava flows that emerge from volcanoes that are very similar to the ones we find on the Hawaiian Islands. These would be the big shield volcanoes. Not super powerful eruptions, but ones that produce lots and lots of lava. In some cases, it's a mountain that's sitting over a hot spot, a very thin part of the Earth's crust, where the magma can well up very, very easily. And what we found is that most of the surface of Venus is covered in this lava. It's a very geologically young surface. One of the things we don't see a lot of on the Venetian surface are craters. Part of that has to do with the atmosphere being so thick, prevents a lot of objects from getting through in the first place. But if you have volcanic eruptions that can fill up craters, those craters can then disappear. So while on the Moon and Mercury, we might have craters that date back billions of years, on Venus, we have craters that may only date back tens or hundreds of millions of years. It still sounds like a really long time, but when we talk about sort of the timelines of our solar system, this makes it a young surface. Certainly not like the Earth, but much younger than other surfaces we'll find on terrestrial bodies, on rocky bodies, the way we do here on Venus.
And the planet, it doesn't have plate tectonics like Earth does. So Earth is actually changing, it's evolving, its plates are moving around, changing the continents and things like that. But Venus is actually locked. And so what is producing all those volcanic eruptions if we're not having plate tectonics and things like that?
Well, a lot of what we think is that early on in the history of the planet, because of the impacts that we saw, that if an impactor is going to be sizable enough to make its way through the atmosphere, those are major geologic events, and they can cause turmoil both inside and outside of the planet. But we also know that planets the size of Venus and Earth can differentiate, where the heavier materials settle towards the middle, the lighter materials rise to the top, and in those situations we have sort of a convection that goes on. It's not something that's going to stay in constant movement the way we have on Earth, but it's enough where we could see for periods of hundreds of millions of years enough movement underneath the crust of Venus to produce a lot of the geological effects that we see on the surface.
All right. And then Justin, do we have any questions from the Facebook here about Venus?
Oh yeah, we have a couple. Douglas was asking how thick the cloud layer is on Venus, if you know.
I know
it's going to be roughly the same pressure you'd feel under about 3,000 feet of water. So this is sizable,
and it's about several hundred miles thick in terms of the atmosphere. Very similar to Earth, but it's a substantial difference in pressure.
And with all those volcanoes, John was asking, is Venus getting larger?
I don't think it's getting larger per se.
Its mass probably isn't changing at all, but
no,
its crust might be changing.
Right. The layering and the changing of the surface layer, but the mass of the entire planet isn't really. It's just this redistributing the material from the inside to the crust.
And Brian was asking if Venus wandered into our solar system, or are we pretty sure that it formed just like the rest of our planets?
Yeah, Venus formed just like Earth did, and actually Venus was very Earth-like. We think in the earliest stages of its life, as the sun grew bigger, it got too hot. It passed that point of kind of the habitable zone and lost a lot of its water, vaporized, and eventually we see the outgassing of sulfur dioxide and hydrogen sulfide and all these things that eventually develop the sulfuric acid clouds and excess of carbon dioxide in the atmosphere. So there is a chance that Earth could very likely be like this in about 500 to a billion years once the sun gets big enough and we kind of get out of that habitable zone, because remember, the sun is getting bigger and bigger and bigger over time, and eventually we will end up potentially being like Venus in the future.
That's why Elon Musk wants to go to Mars.
Well, speaking of Mars, that's a good transition, Justin, because that's where we're going next. We are going to bypass Earth and we are going to fly to Mars. And Mars is getting a lot of the buzz these days because that is hopefully, obviously after we go to the moon, our plan to travel to. And while we're flying, Justin, you want to talk a little bit about upcoming chances for us to explore Mars?
Well, absolutely. If you're in the Florida area, usually based on our stats from our shows, about 80% of you are Floridians. There's some really cool launches coming up this summer. One of them is a precursor to SpaceX's big grand plans to go to this red planet, and it starts with just putting astronauts up to the International Space Station. So SpaceX is going to be sending two astronauts, American astronauts from American soil, from Kennedy Space Center up to the International Space Station. And this will be the first launch since 2011, when the shuttle program ended, that we were not paying the Russians to send our astronauts up into space. So pretty historic launch. Also, it'll be the first launch by a commercial company to put astronauts up into space. So that is happening next month. It's still on schedule. The exact date has not been set, but SpaceX is still targeting mid-May. That's, again, just a baby step towards SpaceX's grand plans to eventually go to the moon and eventually go to Mars. In July of this year, we have a rover, a next generation rover going to Mars, and this rover is heading to the Jezero crater, and it'll be launching on July 17th. It lands, I believe, in February of 2021. I'll post these dates in the notes so you can bookmark them on your calendar. I'm sure there'll be some fun watch parties for the landing, the 7 minutes of terror, getting through the Martian atmosphere and landing. But this new rover is going to be taking 31 samples of the regolith of Mars, and it's got a really cool feature, a drone helicopter that'll detach from the rover and survey the Jezero crater, looking for the best dig sites, because we're looking for biosignatures, any evidence of life. And where do you want to look for that? Well, you want to look for it in areas where there was probably water.
Excellent, Justin. So, Mike, we got some really interesting evidence that Mars was much more like Earth back in ancient times. And one of the coolest features we like to remember when we used to do our shows at the Planetarium, we would always start off with this really cool geological feature. What is this thing that we're looking at here?
This massive scar on the side of Mars is known as the Valles Marineris, the Mariner Valley, and it's a rift valley, very similar to the one that's forming in Eastern Africa. Although it looks quite a bit more like, excuse me.
Well, so that the beauty of doing virtual shows is you have very curious minds behind you asking you questions.
And so what we're seeing is it's a canyon, very much like the one Grand Canyon in Arizona, but made in a different way. The Rift Valley, of course, in Africa, is two tectonic plates that are moving apart. The Grand Canyon, of course, was gouged out by the Colorado River, but it gives us a sense that we did have some real geologic activity in Martian history, but also the sheer scale of something like this. The Valles Marineris puts the Grand Canyon to shame. From one end to the other, this is a feature that's more than 3,000 miles in length. That's effectively the width of the United States. The cliff walls that Derek's pointing out with the mouse cursor range 4 to 6 miles in height. This is Everest height. You could put Everest inside of the Valles Marineris and have the summit not be able to peek over the edge. This is, cruising altitude for a jet airliner. And at its widest point is going to be about 300 or 400 miles across. And so this is an absolute monster of a geologic feature on the surface. And it's not even the coolest part of the planet. There's just so much on the planet where if we go towards the western edge of the Valles Marineris, we see another very, very important geologic feature that's known as the Noctis Labyrinth, the night maze. And one of the striking features about the Noctis Labyrinth is that it looks extremely similar to geologic features that we have here on Earth. So Justin, I'm going to post this question out to our audience. What do we have on Earth that bears a resemblance to the Noctis Labyrinthus? Let's see if we can get any good responses to kind of give us an idea of what our audience is thinking.
All right, let's see if they got it.
All right.
And I'll give you guys the little hint. It is one of the things about Earth that makes it so incredibly special.
We'll give you all just a few more moments until we reveal the answer. Or unless Justin tells us that somebody has already answered this question.
We've got one reply saying caves.
Caves, okay.
Someone says river delta.
Okay.
I don't think we need to go much further because that's going to be the case. This is very, very similar to what we would see in a dried up riverbed or in the dried up deltas areas on Earth. And what we believe is that at some point in Martian history, that this area of the planet was a very large river, the volume of which is probably right about that of the Amazon River. And once we're able to sort of flood the surface, if we were to pick a mean sea level for the planet and flood the rest of it, about 45% of the Martian surface would be covered in water. And so go back a billion years and you have a planet that's likely identical to Earth in terms of its conditions. A little lower gravity, probably a little bit different composition of atmosphere, but one in which liquid water existed on the surface in huge amounts.
The other thing that we can see too is when Mike was talking about the Rift Valley, basically the plates of Mars rifting apart, is we also see evidence of geological uplifting, particularly a plateau called the Tharsis Plateau. And we have several large shield volcanoes that have formed out of this result, including the largest of them all. In fact, it's the largest volcano out there in the solar system and also considered to be the tallest mountain in the solar system. This is Olympus Mons. And Olympus Mons is the mega of all of the mountains. This thing, you can literally, for those that are watching, again, most of our viewers here are from Florida, you could stick the entire state of Florida inside of this mountain. And the caldera, which we would have a slow progression of lava, so this is a shield volcano, just like the volcanoes on Earth and on Venus, you would have a slow oozing of lava. That whole area where the lava would have come out of this would have been the size of Central Florida. So again, a very, very, very large volcano. And you could stack 3 Mount Everests on top of each other to get to the height of this mountain. So this is a very, very large object. So incredible that we're able to actually, to look at this and see all this ancient geology of Mars. But what happened to Mars? Why is Mars as it is today? Well, there's a spacecraft orbiting around Mars now called MAVEN. And let me see, I think we might have MAVEN. We do not have MAVEN on this profile. But MAVEN is a spacecraft that's orbiting around Mars, and it's actually looking at the atmosphere. And just recently, we discovered that the solar wind, as we were talking about with Mercury, the solar wind has slowly removed the upper atmosphere of Mars, thinning it out over billions of years. And over time, eventually made the atmosphere so thin that essentially we don't have the atmosphere that kept the water, kept the temperatures warm, all that. And essentially, Mars is pretty much a dead version of itself as it was back in ancient times. We think that Mars could have been very Earth-like in ancient history, and how we know that is because there's a rover there right now. There's a rover there right now called Curiosity. And Justin, do you want to talk a little about Curiosity since you're the space explorer guy? And you just have all those really cool rockets and stuff behind you, so you're just by exclusive explorer guy.
Well, Curiosity has lasted. What's been amazing about the Jet Propulsion Laboratory, JPL, yeah, and NASA is they find a way to just get some longevity out of these machines. And Curiosity, I believe, was just originally supposed to last about 90 days, and what's it been going on now? Almost a decade.
Yeah, it's been a long time.
I don't know. It's been a while, but. Curiosity's pretty beat up. It's done a lot of work. Its wheels are almost gone. And it's right now it's doing a little bit of rock climbing. And can you show our little mountain that it's on its way up here?
Yeah. So this is basically where the Curiosity would have landed. And essentially it landed in an ancient seabed. And the mountain that's climbing is actually climbing in a very rich geological strata, basically layers of Martian history that show some really cool stuff. So that's Mount Sharp off in the distance there.
So Curiosity's on its way up Mount Sharp, and scientists are fairly confident that it might be able to find some activity up there. So it's been marching up there for, gosh, probably a good 6 months now, and it just inches along each day, and just a wonderful machine. Perseverance, which will be leaving again in July, is based on a lot of the same technology. It's almost a mirror image of this this technological marvel. So it's good. Perseverance has a little bit more of a detailed camera system, but other than that, it's built on a lot of the same technology. So we're going to see what Curiosity does over the course of its lifetime here, what's left of it. But we've got a friend heading there to visit it now.
That's right. Now, to change our subject a little bit here, you might be thinking we're looking at a baked potato, but this is actually most likely a captured asteroid. This one is called Phobos. This is one of the 2 moons of Mars. And Phobos and Deimos, for those that live in Central Florida, could fit inside Seminole County. And now, Seminole County, for those that are not in Florida, is a really tiny county. So we're talking about 35 square miles in size, maybe 40 miles square size. So these are very, very small moons. And again, being so close to the asteroid field, both of these moons, Phobos and Deimos, can fit inside our small county of Seminole County. And, again, these are actually being pulled in by Mars. The Martian gravity is pulling these in. So eventually, both of these moons will basically fall onto the surface of Mars and crash land. So kind of will be an interesting event. If we were to develop civilization on Mars, that's something they have to worry about at some point in history. All right, so once we pass Mars, actually, do we have any questions about Mars before we continue on?
Let's take a look here. So Mike was asking if you could show Hellas Planitia. I don't know if you can pull up that impact crater or not.
So let's see here. Let's see if we have those in here. We do. We can show that. Let's go ahead and jump down to the surface and take a look. Now we have the ability to. Now, of course, we're at nighttime, so we're going to need to speed up time here. All right, let me zoom out a little bit here just so we can see. Here we go. All right. And then what I'm going to do now is I am going to open up a resource here. We actually can download some other data points here. So we're going to download. We're going to add some new resolution maps here to give us a little bit better resolution of the surface. So we're going to download that right now. And as you can see here, we're going to go and zoom in on Hellas Planitia. So do you guys want to talk about this area? What's special about this area?
Well, what's really special about Hellas Planitia is it is one of the largest true craters in the entire solar system. I think it's 1,500 miles across, and it's there are suspected craters, and then to use the proper term, there are unambiguous craters, and this area, Hellas Basin, is one of those. This is reaching from here out to Chicago. It is a huge crater, and is one of the lower lying areas of the planet. So someplace that would have been filled in with water if the planet itself still had oceans. But one of the cool things is actually last year, the Mars Reconnaissance Orbiter, which has an incredibly high resolution camera on board, went over Hellas Planitia, and one of the pictures purported to show a rock formation that looked an awful lot like the Starfleet insignia from Star Trek. So, one of those little things, everybody sees everything on Mars and in Martian rocks.
You remember the Bigfoot on Mars thing, didn't we, Mike?
13 years ago, there's a Bigfoot on Mars. It was 4 inches tall. But at the very least, this huge crater in the southern hemisphere of Mars that may or may not have the Starfleet logo in it.
All right. Anything else, Justin?
We had a question if any of the volcanoes are still active.
No, so everything, Mars is pretty much, its core is basically stopped. It doesn't have the same heating exchange that Earth and Venus are. So yeah, all the volcanoes on Mars are extinct. So no fears of volcanic eruptions on Mars. All right, so are we ready to change gears a little bit? We've talked about some terrestrial worlds, terrestrial planets on in our program. Now we're going to go ahead and change it up, and we're going to visit some other types of planets. We're going to go ahead and visit the next planet, the king of all the planets. And of course, that is Jupiter, right? So now we've looked at Mars. We also are looking at Jupiter, and eventually we're going to look at Saturn. And while we're flying to that, Mike, can we see these planets in the sky right now?
If you want to head out a little bit early, about an hour or so before sunrise in most places on Earth, you'll be able to catch all three of the planets clumped pretty tightly together, rising over the eastern horizon. And Jupiter is going to be your brightest, Saturn next, and then Mars. But as the planets continue to move, Mars is going to surpass both of them, given that it's moving faster in its proximity to Earth. But Jupiter is going to be the one that continues to shine the brightest. And as you can see, when we call it the king of the planets, we mean it. This is an 88,000 mile wide planet. That's enough space for 10 Earths, 11 Earths across the equator, more than 300 Earths inside of it. You can see that this is a gas planet. It's made primarily of hydrogen and helium. And because of that, because of its spin, it's a planet that rotates once every 10 hours or so. We have these beautiful weather bands, zones, and belts that are visible in the cloud tops. You may also see some large storms. We just saw the Great Red Spot go by. These are cyclones with winds that could be in excess of 600 miles per hour. And you may also have seen a few large black dots on the tops of the clouds. Those are not atmospheric features at all. Those are going to be the shadows of 4 of Jupiter's largest moons, the Galilean moons, Io, Europa, Ganymede, and Callisto. Because they all orbit in the equatorial plane of Jupiter, from our vantage point on Earth, they will pass in front of and behind. You can see a shadow just went by there, and we can see those shadow transits through telescopes from the surface of Earth.
So this great red spot here is still a mystery, isn't it? And Justin, we have the Juno mission currently visiting Jupiter, learning a lot about the what we call the magnetosphere and the radiation zones and things like that found in the auroras. But it's also trying to figure out what this great red spot truly is, right?
Yeah, Juno really wants to know, what's happening inside this gas giant. And, in the inner planets, we've got these, rocky metallic bodies. But as you get further out, our knowledge of what's going on deep inside these gas giants is still very limited. And Juno is doing just some very strategic orbits, very elliptical orbits around Jupiter. And they've got to be very specific when you orbit Jupiter, because the radiation can damage spacecraft very easily. So they have to dip through those radiation belts to really study the interior. But Juno has been orbiting Jupiter, 4 years now, and is very similar to the Cassini mission. We'll probably talk about that when we get to Saturn, but hopefully bringing back a lot more detail about how these gas giants truly formed and what's going on below the atmosphere.
So the planets Jupiter and Saturn and some of these other large planets out there in the outer solar system, they have a large collection of moons. And Jupiter and Saturn are constantly competing with each other for the number of moons. And right now, Saturn just surpassed Jupiter, but Jupiter still is second place with 79 moons. And some of the most interesting moons in the solar system. And we don't have time to visit all of them, but I think we have enough time probably to visit one of them, and hopefully maybe some other times we'll maybe do some other programs specifically about each planet. Maybe we'll explore more. But I want to go ahead and explore this moon. I think this is a very important moon here. Mike, what's special about this moon? It's called Europa.
It's that the aliens that come from the moon will be known as Europeans. It's probably the most important thing. The second most important thing is that Europa is one of the few places in the solar system that we know has liquid water. The surface itself is comprised almost entirely of water ice. It's a crust that's many tens of miles thick. And so it's highly unlikely that we would be able to very easily get into this subterranean ocean. But we know because of the gravity and tides, the tides that come from being this close to the king of the planets, that there's enough heat inside of Europa to melt the ice and cause it to have, at the very least, what we would think of as a saltwater ocean. The chances for life to exist on a moon like Europa are much, much higher than they would be elsewhere. Of course, we're not saying that there's absolutely life on Europa. There are a number of problems that come from being a moon a few million miles from Jupiter, things like radiation and bombardment. But Europa has geysers on the surface that we can see from Earth. We can test to see what the makeup, the elemental makeup of that spray is, and we can figure out what's going on inside of the moon. But to have a moon with more liquid water inside of it than there is liquid water on the surface of the Earth is still pretty fantastic. We're starting to find out that Europa really isn't the exception, but maybe is more of the rule in the solar system. Like we said earlier with Mercury, ice, specifically water ice, is not uncommon in the solar system. It's in the right conditions where we get that to melt down into liquid water the way we do inside of Europa.
And Justin, there's a spacecraft that's being proposed to launch to Europa, right?
Yes, the Kuiper mission. The Kuiper mission is, I don't have the dates off the top of my head, but this mission would be to travel to Jupiter, land on the surface of Europa, and drill into this ice. Kuiper might not be the drill itself. It might just be the first stage of a surveying mission to find the proper places to drill, and then a secondary mission to actually do the drill and bring those samples back to Earth, or just study them right there on the surface. Because if you're a sci-fi fan and you read the Andromeda Strain, you want to be very careful what you bring back to Earth, right? But
We don't want a pandemic of an alien virus.
Right. We have enough problems here on Earth to bring anything back. But yeah, the Clipper mission's pretty exciting. Keep an eye on that over the next decade. That will be traveling to Jupiter, landing on Europa, surveying this icy moon, either doing the drilling or prepping for the next mission to drill into the surface and take samples right there.
And all right, this is some really exciting stuff. And there's other moons of Jupiter like Io and Ganymede and Callisto and other moons that are just as exciting in many ways. But we have only so much time left, and we still have other things to explore. But do we have any questions about Jupiter before we move on to our next planet?
Let's see. One question, one comment about the radiation bands generated by Jupiter, and absolutely.
Mike, you want to answer that question? I'll give you that one.
Yeah, because of Jupiter's absolutely enormous magnetic field, largest magnetosphere of any of the planets in our solar system, the interaction between that and the solar wind and solar radiation coming from the sun causes us to have really large amounts of charged particles in the area. And because of moons like Io, which actually travel through these radiation bands directly, what we have are electrical discharges that can travel between the planet and the moon 1.5 million miles away. We have the brightest and most colorful aurora in the solar system at both the north and south poles of Jupiter. And so all of this radiation could irradiate life on any of the four inner moons, to say nothing of moons further out. But when you combine solar wind and the magnetic field of Jupiter, you're going to get these very, very dangerous radiation bands as well.
So it's definitely something that we need to be concerned about if we want to send a human mission to Jupiter, but also for any chances of finding life. All right, so what we're going to do now is we're going to go ahead and fly to our next planet, the ringed planet. Usually if I have a voice message on my phone, and one of the things it says is name your favorite planet, and 9 out of the 10 times it's Saturn. There's also occasionally somebody saying Earth, and there's always that one person that says for 50 minutes why they think Pluto is still a planet and all that stuff. But Saturn really seems like everybody's all-time favorite, and I think because it's just so iconic and how it looks. It just has this beautiful, ring system. It just looks like that traditional, stereotypical planet that you see when people, draw a planet. It just has this really beautiful thing. And if you get a chance to look at Saturn through a telescope, it really does look like what we're showing you here. So, of course, the ring system is what's really kind of steps Saturn. The atmosphere of Saturn is very similar to the atmosphere of Jupiter, mostly rich of hydrogen, a little bit of helium, some other trace gases as well. But really what stands out Saturn is its ring system. And those rings are not made up of they're not solid disks. They're not like Frisbees. But if we were to actually look at Saturn's rings, which we can actually do, we can zoom in on these rings and we can actually look at them in greater detail. So we're going to go ahead and fly into the rings of Saturn, and we're going to go ahead and take a look at those ringlet systems. And Cassini, which was a mission around Saturn, it seemed like forever. It's been there we actually just recently sacrificed it to the atmosphere of Saturn because it exhausted its mission. But it has opened up a lot of knowledge of this planet. And one of the things that it really spent a lot of time on was learning more about these rings. So as we get lower and lower, you can see how the rings are actually made up of these different bands. And in those bands are these things called shepherd moons that actually slowly herd the rocks and ice in place. You can actually get little wakes from the gravity from some of these moons as well. But as we get closer and closer and closer, you'll be able to see those tiny little rocks and ice. So while we go down there, what are some of the things we learned about the rings? How did they form? Mike, what was the science we learned about the ring systems with Cassini?
The sort of main theory we have right now is that the rings themselves are started in two distinct areas. Because we have two different populations of objects in the rings, ice and rock, we believe that the rocky parts of the rings, the inner rings, were likely due to a rocky moon that ventured a little bit too close to the planet, was ripped apart by the tidal power of Saturn. What we're also seeing is that the outer rings, which are primarily composed of ice particles, are being replenished day in and day out from ice geysers that emerge from one of the moons of Saturn. It's a moon called Enceladus. If there's any moon in the solar system that gives Europa a run for its money, it's going to be Enceladus. And so these ice geysers will put ice into space, and then, of course, given the immense gravitational field of Saturn, will fall into place around the equator and oftentimes take their place at the edge of the rings. The rings of Saturn are what we would consider a transient feature. It's something that does not exist for a very long period of time when we're talking about the cosmic timeline. They didn't form with Saturn. They are not going to be there in a billion years. We're sort of in the Goldilocks zone of roughly 25 to 50 million years that most astronomers agree the rings exist in. And so at some point, the rings will cease to exist in the grandeur and splendor that we see them in today, and be a bit more like the ring systems of Jupiter, Uranus, and Neptune, which are composed primarily of dust and ice.
Yeah, so this moon here is Enceladus. Those bands that you see there are those ice geysers Mike was talking about that would have sprayed this ice. And it actually, we discovered with Cassini, is it does rain ring material in the atmosphere. So that's why we're losing those rings, because they're falling into the atmosphere. But one of the most interesting moons of Saturn, and by the way, Saturn is the lord of the moons now at 83 moons, is of course Thanos' home. No, not really. Titan. And Justin, can you tell us about a new mission and why it's important for us to go to Titan? What's unique about Titan?
Well, Titan, boy, if Titan was not currently trapped in Saturn's gravitational pull, it meets all the qualifications of a planet. It's got an atmosphere. It's got a fairly good size. Titan by itself could be a planet. It's the only moon that we've discovered that has an atmosphere, and Cassini had a special probe on it called the Huygens probe. And when Cassini arrived at Saturn, the Huygens probe detached from Cassini, and NASA and ESA, they really wanted to see what was going on beneath that thick atmosphere. And when the Huygens probe flew through this atmosphere, you can actually watch this video on nasa.gov. It's absolutely fascinating. And when this happened back in, gosh, it's been, I don't know, a dozen years now, I just can't believe that there weren't parades, ticker tape parades, and parties in the streets, because this probe, as it got through the atmosphere, it found a surface very similar to Earth. Liquid rivers, liquid lakes. Now, we're almost 1 billion miles from the sun, so this is way too cold for liquid water. Liquid methane, liquid ethane. The surface of Titan is covered in it. And NASA is working on a mission now called Dragonfly. And Dragonfly will be to return to the Saturnian system, land back on Titan, and very similar to the helicopter drone that is that will be heading to Mars this year. The Dragonfly drone will do the same thing, survey this very, very cold moon with a lot of the elements that are the building blocks of life. So very exciting to see where Dragonfly will go and what science it will bring back.
This is an incredible time that we live in. We live in a time where we are exploring future worlds, and potentially one day we may have the key that unlocks the evidence of life on another planet. Any questions about Saturn before we finish up our last haul of the tour of the solar system?
Surprisingly, no questions about Saturn.
All right, I think we're getting to that point now where we're getting so far out, we're ready to kind of hightail it and talk real briefly about some of these planets. Now, the next couple of planets we're going to visit are actually our least most understood of all the planets in our solar system. But of course, the next one definitely gets a bad rap because of its name, and it's been the butt of many jokes for years and years and years. Of course, this is Uranus. Now, of course, we've learned in our school time that a lot of us learned it was Uranus, but actually the proper way is Uranus or Uranus, but you don't want to sound too pretentious saying Uranus. But a little bit about Uranus. Uranus is flipped on its side, most likely caused by, again, another massive planetary collision. Again, the rings of Saturn of Uranus are primarily rocky, so that gives us a possible clue to what happened to the fate of Uranus. Being that it's flipped on its side, it actually rotates up and down instead of side to side like the other planets. And it has a year of over 84 years. So 42 of those years are facing in one direction and 42 years are facing in the other. Now, there's some really cool tidbits about the atmosphere of Uranus. It's actually more of a slushy. It's so cold at Uranus and Neptune that the atmospheres are more like slushies. But don't think of it like a Slurpee, but think of it like, methane, ammonia, hydrogen, helium, stuff that you don't, there is some water in there, but not exactly something you necessarily want to take home and drink. But we think there might be an ice core around Uranus. So pretty nifty, but hopefully in the next couple of decades, we'll have a chance to go back to these worlds. And what we're going to do is we're going to go ahead and jump to Neptune. And again, Neptune is kind of like Uranus. It's kind of, again, a little bit least understood, but we do have some interesting facts about Neptune. Winds have been recorded at over 1,100 miles an hour. Has solid ice clouds, and it's actually the youngest planet in our solar system. It actually is slowly cooling down from its initial formation, which creates a differential or a change in temperature from the core to the atmosphere. That's what we think is generating those massive winds of Neptune. And there are moons around Neptune that actually have ice volcanoes, but instead of water, it's frozen nitrogen. So pretty neat. But again, hopefully in the near future, we're going to have new spacecraft that are going to be developed, and we can go out to these outer worlds. But the last place that we're going to visit is Pluto. And, Mike, tell us about what's this remember this controversy about Pluto, right? This whole thing, every time you do a program about Pluto, there's always that one person that gets really hot-headed about Pluto not being a planet. But what's really the story behind that?
It's a story where we have people alive on this planet that were born before we knew Pluto was an object in the solar system, and who lived until after it was reclassified. And so 1930, Clyde Tombaugh discovers Pluto on a series of photographic plates, compares the two, and sees this little object moves over the course of a few days. They do a little bit of math, find out its orbit is out there beyond Neptune. And throughout the 20th century, Pluto becomes everybody's lovable ninth planet. A few years ago, about decade and a half ago, the International Astronomical Union met and redefined what they thought a planet should be. A planet should be spherical in shape, so large enough to be spherical. It should orbit the sun. This is an important aspect. And it should be able to clear its orbit of debris. Since Pluto is not a very large body, about 1,800 miles in diameter, its gravity has not cleared the entirety of its vicinity in the solar system of other solar system debris. That doesn't make it any less of an object. It is really now the largest of the dwarf planets rather than being the smallest of the major planets. It's not considered a minor planet the way the asteroids are classified. It wasn't demoted. It wasn't shunned. It was simply reclassified. And then when we got there, just a few years ago with the New Horizons space probe, what we discovered is that Pluto was far more interesting, far more alive as a solar system body than anything we could have imagined. Nitrogen lakes, mountains, and cryovolcanoes that erupt um, nitrogen and methane rather than lava like we would here on Earth. Many fewer craters than we expected, which means that the surface is much more geologically active and young than we could have anticipated. And there's a very good likelihood that there is liquid water somewhere inside of Pluto. So for all of the talk of demotions and things of that sort, Pluto is still an amazing place, one that unfortunately for us, is 4 billion miles from the sun, which makes getting to it a little bit more difficult. It's why we've only had one space probe fly by in the space age. But alongside its sister planet, or at least its double planet, moon Charon, we have two bodies that are actually so close to each other in mass that they orbit around a point outside of Pluto. So Charon does not orbit around Pluto necessarily, as much as these two objects orbit around a center of mass between the two of them. This would allow us to justify calling Pluto and Charon a double planet, which then makes it even more special than when it was before. But it is the edge of our inner solar system, the solar system that we all kind of grew up with. It is the edge of the Kuiper Belt, a group of objects that rings the solar system and is many, many times closer than the sun than the edge of our solar system, what's known as the Oort Cloud. It's a cloud of comets that stretches perhaps as much as a light year away from the sun. That's 6 trillion miles. That's a quarter of the distance to our nearest star. So we're still nowhere near the edge of the solar system as scientists, as astronomers would define it. But Derek, if we were to start to fly away from
Before
Pluto,
we go, do we want to talk real briefly about this really cool? People always ask about this heart-shaped object on Pluto, and do we want to briefly talk about what this is real quick before we leave Pluto?
well, we're looking at a nitrogen surface, a nitrogen rock surface, in which we have a surface that's a little less dense than what we might be used to on Earth. What you'll notice, though, is that in the center of this huge area, very few craters. And that means we're seeing a lot of geologic activity. So that even though a place like Pluto would be heavily cratered, it's got no real atmosphere to speak of, something is replacing those craters. Something is eroding them away. And so we're seeing that there is some sort of geologic activity on Pluto, even 4 billion miles and 350 degrees Fahrenheit below zero, the conditions we'd find on the planet. This is wholly unexpected, and really has kind of whet the appetite for astronomers to see what other Kuiper Belt objects share their characteristics with Pluto.
And as Mike was saying, if we continue out, leaving the depths of Pluto past the Kuiper Belt, we move into an area called the Oort Cloud, which is basically home to billions of chunks of little pieces of ice that are slowly being held, or very, very gently being held by the sun. And just recently, though, we had a comet. We still do have a comet that has come in from the depths of the solar system, Comet Atlas. And we think that a lot of these chunks of ice over time get pushed in by nearby star passes and things like that, and that creates the paths of the comets. And so if you join us tomorrow night for our virtual star party, you'll be able to see Comet Atlas. It might be our last time to see it as it slowly disintegrates, which unfortunately is happening to it. But Mike, you were mentioning about the Oort Cloud earlier, about zooming out and taking a look at this.
Going ahead and just kind of given our time constraints here, let's just go on ahead and take a nice jog out from the solar system right now. The Oort Cloud is the edge of the solar system as astronomers would define it. It puts us a quarter of the way to the nearest star. And our nearest star, Proxima Centauri, is about 4.25 light years away. Light takes 4.25 years to reach us from that star. And as we move back even further, what we're going to begin to notice is that the star patterns that we're familiar with here on Earth, the constellations of antiquity and of modern times, begin to disappear. We are looking up into a sky that is three-dimensional, and those stars all have differing distances, that as we move away from the sun, we see fewer and fewer of those common constellations because our perspective on the universe is changing as well. What you see behind the Oort cloud in the solar system as all of the constellation lines converge towards our sun is the band of the Milky Way Galaxy, 110,000 light years across. It is our home in the universe. It's a barred spiral galaxy. We're a third of the way out from the supermassive black hole in the center to the edge, and we're one of billions, if not trillions, of galaxies in our universe. So one star out of about 500 billion in a big galaxy that's part of another 500 billion galaxies in the universe makes you feel kind of small. But on the flip side, the ability for humans over many, many thousands of years to have come to this understanding of the universe where we know what our place is and sort of how we compare to other galaxies and other star systems, both in our celestial home and without, you can see that for all of the stars we see in our sky, with your eyes, you can see about 3,000 light years away. Those are the stars that make up our neighborhood in the Milky Way. And then you can see everything else. We are a really small spot in a really, really big place. And yet, as we fly back towards the Earth now, we're all these people on this we're an 8,000 mile wide rock, 28,000 light years from the center of the Milky Way, and 93 million miles from this million mile wide star that just is average in every single way, shape and size and time. How unique our vantage point in the universe is, and just how much more there is for us to know and to explore. So as Derek makes his way through the Oort cloud and through both the outer and inner solar system, hope you've all enjoyed our journey through the solar system and now a little bit through the galaxy this evening. Justin, do we have any more questions we might want to take before we end the show tonight?
We actually had one about Saturn that I missed. We had a question about the rings and was asking him how thick and how wide that ring system is.
It's for you, Mike.
Justin, can you go ahead and repeat that real quick?
Oh, sure. They were asking about the ring system of Saturn, how thick that ring system was and how wide.
It's going to depend on where in the ring system you are. But we think that at a maximum, the thickness of the rings of Saturn are only going to be about 600 or 700 feet thick. In some cases, you could walk through the rings of Saturn in a matter of minutes. So this is a very, very thin ring system compared to its width, would stretch almost from the Earth to the moon, and yet no more than maybe 1/4 mile thick.
Now here we are at planet Earth, our home base in the solar system, and just one of the things that we like to do about this show as well is remind everybody that there really is no place like home. I mean, we have adapted to this planet for a very long time, and we are perfect for this place. And as we explore the other elements of the other places in the solar system, how important it is not only for us to explore the solar system, but also to appreciate our Earth. So we like to hope that through all this going on in our world right now, that we can band together and work together and hopefully be able to start taking care of our planet even more and appreciate just how valuable our planet really is as we explore these other worlds. Again, I want to thank all of you for joining us tonight for our program of Earth's Neighborhood. Just remember that we have other shows going on. Actually, next week for our public show, which again will be Thursday night at 7, we have another program called 2 Degrees Earth on Edge, is because it is Earth Day next week. We also are celebrating Earth Week. We're going to be talking and tackling climate change, but we're also bringing in a person that has actually done some really cool science visualization in the planetarium world, and showing that with you all then. And but don't forget, we also have our virtual star party tomorrow starting at 9 p.m. So definitely follow us. Be sure to subscribe to us also on YouTube, as well as let people know about our Facebook page and all the different offerings we are doing throughout the time that we have going on right now. So any last minute questions before we officially finish off our program? Anything else, Justin? Are we good? Oh, Justin, you're muted.
Good catch, thank you. We had one more question about Pluto from Hunter, and he was asking any outlook on a reclassification of Pluto due to what we've learned from New Horizons.
I think we have to kind of get away from this bad negative look on Pluto being a dwarf planet. I think as we look and explore more of the outer solar system, particularly with Ultima Thule, which actually New Horizons passed by recently, we're learning that there are objects way out there, and who knows what other small objects. And so Pluto could be a part of this growing large collection of dwarf planets. And I think that Pluto is starting to resemble a lot more of its dwarf planet kind out there. And right now, I think even though it has a really cool all these really interesting surface features and events and things like that, I think though it just still shares a lot of the characteristics with its other kind, and I think it's better to continue calling it a dwarf planet. But then again, I'm not to say that. The International Astronomical Union, the organization that does name objects in the sky and in the universe, may change their mind. So I think it's up for them, and we'll see what happens.
Well, I want to echo what Mike and Derek said. The NASA budget is about $22 billion a year. And that's actually less than 0.5% of the federal budget. Less than 0.5% is all we have to explore space. And, you've taken a tour of the solar system. You've seen how difficult it is for life to exist anywhere else. And we're learning now how fragile our planet can be. So it's important to continue to support space, because when you break down those numbers, it really comes out to, per person, about the price of a cup of coffee a week. So it's, in my opinion, it's well worth the investment.
Absolutely, definitely. Yeah, if you're willing to spend some money on some coffee, you can spend some money for science. It's pretty cool. All right, well, again, I want to go ahead and thank all of you that are watching on Facebook Live for joining us tonight. What I'm going to do now is I'm going to go ahead and stop the live stream at this point. So thank you much, everybody, and we hope to see you at a future event. And then, of course, we're still recording. We're going to be uploading this to our YouTube channel for people that want to watch for later purposes. So we're going to go ahead and stop that as well. So again, thank you all very much for taking your evening or afternoon or morning or whenever you're watching this to enjoy and explore the solar system with us. And with that, my name is Derek Demeter. We have Mike McConville, and we have Justin Cyril. We even have the Uniview simulator. And thank you all, and we hope to see you again in the future. Take care. Have a great day.
Be safe.
Be safe. All right.